All right, here we have a little short video. We're going to practice identifying the type of solid substance. Maybe by the end of this, you'll start understanding more what our previous video was about. This is our key to answer the type of solid. We're going to put I for ionic, CN for covalent network, M for molecular, and MT for metallic. In our first example, we have silver chloride. So I have a metal and a nonmetal. The presence of that metal is critical for you to identify, because if you see a metal, it's either going to be metallic or ionic, but it's in a compound that breaks the tie, that makes it ionic. So the attractive force, what I mean here is what makes this compound a solid? What is the force? And the force here is the ionic bond. Number two, we have silver. So if I have a piece of silver, we would classify that as a metallic solid, held together by those metallic bonds, the electron C. Number three, we have diamond. Of course, that's hard if you don't know what diamond is, but diamond is carbon, and so it's a nonmetal. So that's going to really put us into covalent something. And if you know diamond, you know it's really hard. It is a covalent network. If it was molecular, it would be soft, and you could probably squeeze a diamond. So the thing that makes it a solid is a covalent bond. Then we go to sodium chloride. Again, sodium's a metal, so we're going to have another ionic. All right, why don't you hit pause, go through these, see what you do. You're going to miss some of them, but when you come back, I'll go through them with you. All right, let's see how you did. Number five, we have sugar. So sugar looks like tiny crystals. It looks like salt, but it turns out that sugar is actually a molecular species. Let me remind myself, yeah, M for molecular. So it's a molecular covalent, which means it's not covalent bonds making it a solid. It's actually those intermolecular forces, specifically dipole-dipoles and hydrogen bonds, and even some LDLs, London dispersion forces. So we'll learn more about that, but it's going to be a molecular solid. Gold, I think every one of you would pick that as a metallic solid. So with metallic bonds. Silicon is an element, it's not a metal. So similar to carbon, it's able to go into those 4 dimensions. sp3 hybridization is very easy. So here we're going to see a covalent network to make it a crystal, held together by the covalent bonds. Aluminum is a metallic substance. Metallic bonds hold it together. Calcium sulfate, you may have seen that in class, but nice, pretty blue crystals. The presence of that metal there in a compound is going to point us toward ionic. And so ionic bonds is what makes that a solid. Quartz, we talked about in the video, quartz sand. So we have no metals there, we have a metalloid. That's going to help us with covalent network. So covalent bonds form this lattice. What do you think 11 is? What'd you put? Because ice has pretty crystals, but ice is made up of H2O, so it can't be ionic. Is it covalent network? The answer is actually no. This is molecular, because water is a discrete molecule held together by IMFs, specifically hydrogen bonds. What about wax? I bet that wasn't quite as hard. Wax is also a very soft substance, so from that alone, I hope you classified that as molecular, again, held together by IMFs, very weak. Iron 3 bromide, the presence of the metal, ionic. And then number 14 was this little nice slice of heaven here. I put an asterisk next to it because it is actually pretty hard, difficult. It's also hard, but I meant difficult. Boron nitride has a metalloid. So that, again, that metalloid, and it can go into 3 dimensions with boron through sp2 hybridization, we're actually going to get a covalent network held together by covalent bonds. That one's pretty hard. For a covalent network, when you see carbon, inorganic carbons, so diamond, graphite, things like that, silicons are covalent network, and then other things that form like metalloid crystals are probably going to be covalent network. A lot of that just comes with learning and experience. If you have any major questions about this, come by and see me.